So today we're working with complex fractions, and complex fractions means there's a fraction inside the fraction. So it looks really complex, but we need to work with something else first. We're going to be working with the least common denominator, which is called the LCD, or we also call it the least common multiple, which is the LCM. These are really the same thing, but when we specify LCD, that means we're only looking at the denominator, not all of the terms. Okay? So the least common multiple is the smallest number that all terms can divide into evenly. So it's kind of the opposite of GCF. We're not looking for the biggest one that goes into those. We're looking for the smallest that the two numbers go into. So it's the kind of the opposite way of thinking.
Isn't it a small sum?
Right, correct.
You said divide, and it says divide.
No, the number is divide into because we're dividing the two given numbers into the common multiple. Okay, so to find LCD or LCM, we have a couple steps. If it's something that's a little complicated, we factor it if we have to. I'll show you how to do that, but we're really not going to need to. Step 2, if they share the same factor, we only need one of them. Anything that's not in common, we also need. And then step 3, we're going to multiply all of that together to get the least common multiple. Okay, let's practice doing this. So here's 3 examples, and we want to find the LCM of each of these. Okay, so we're going to do the first example using the factorization, but after we do it once, you're not going to need to do it anymore. So let's look at 5. Does 5 factor down to anything smaller? No. So the only factor in 5 is 5, right? We're looking at prime numbers here. Okay, what about 45? How does that break down? Okay, let's do the factor tree. 45 breaks down to 9 and 5, and then 3 and 3. So how could I rewrite 45? 3 times 3 times 5, right? Okay, what do they have in common?
5.
There is a 5 in common. Nothing else though, correct? Now step 2 says if they share the same factor, in this case 5, you only need 1. So we don't have to list 5 twice. We only have to list it once. Anything that's not in common we also need. So we do have to include the 2 3s there. Okay, so what would my LCM be? My LCM here would be 3 times 3 times 5, which is 45. So my LCM in this case is 45.
Is that just a coincidence, or is it always?
It's not always going to work that way. Another common multiple that they would have is 90, correct? 45 goes into 90, and 5 goes into 90, but it's not the smallest one.
Okay.
In this case, both 45 and 5 go into 45, so it just so happens to be one of the numbers. It won't always be that way. But you guys kind of see what I mean on how to do this by factoring? Eventually you're going to be able to just do this in your head. We could do the next one in our heads if we wanted to. 3 and x. We need the least common multiple. What number would go into both? Would 3 and x both go into? 3x. That's right. 3 goes into 3x, and x goes into 3x. So our LCM in this case is 3x. Okay? What about xy and y squared? Okay, David guessed y. xy squared, that's the answer. Should we do it by factoring first? Let's look at this. xy factors out to x times y, right? And y squared factors out to y times y. They have one y in common, so we only have to count one of them. So the LCM would be y times, and then we have to count everything that's not in common, x and that second y. So times x times y. So what would my LCM be? XY squared. And let's think about it. Does XY go into XY squared? Yeah. Does Y squared go into XY squared? Yep. So we're actually going to use the LCM and LCD when we are trying to simplify the complex fractions. So, to simplify a complex fraction,
Don't you wait a minute, hurt.
first thing we have to do is we need to find the least common denominator, and we do that exactly as we were doing up here, but we're only looking at the denominators, so we're only worried about what the denominators are. We multiply each term by the LCD to get rid of the fractions. Okay? After we get rid of the fractions, we will combine like terms, and then we will simplify just like we did yesterday. Okay, so this is what a complex fraction looks like. X over 5, all of that over x over 5 plus x squared. Okay, now step 1 is we want to multiply each term by the LCD. And since we're specifying the least common denominator, we're only concerned about the denominators. So in this case, it's just the 2 5s. So what would the LCD be here? 5. So we're going to multiply each term by 5, all of them, every single term. So we have to multiply x over 5 by 5. We multiply the other x over 5 by 5, and we multiply the x squared by 5. So let's multiply. What happens here when I multiply by 5? The 5s cancel. What about down here? Those also cancel. Does anything cancel here? No, but it is multiplication, right? Okay, so let's rewrite this. Our LCD was 5. Okay, so what's in the numerator now?
X.
Just an x over x plus 5x squared. Are we finished? We can simplify some more. Can you see anything that we can simplify? Those x's. So let's factor out an x in the denominator. So it's going to turn into 1 plus 5x. And now what? Those x's cancel. So what's left in the numerator? A 1 over 1 plus 5x, or we like to write the x's in front so we can actually flip them to become 5x plus 1. Same thing. And that's our answer. Okay, example 2. We have x over 3 minus 6 over x plus 4 over x. Or 10 plus 4 over x, sorry. Okay, so we're looking for the LCD, which means we're only concerned about our denominators, which in this case is 3 and x. So what would the LCD be? 3x. So let's multiply every single term by 3x. Okay, so we multiply every single term by 3x. Question, when I'm multiplying every term by 3x, what property am I using? Okay, so our LCD was 3x. The 3's canceled here and the x's canceled here, which gave us x squared minus 18x over 30x plus 12. We factored both of those using GCF, but that's our answer because nothing canceled. Sounds good? Sounds awesome. Okay, example 3. All right. 1 plus 1 over y over x plus x over y. Only looking at your denominators here. What's the LCD? Y. We do not have to make it a y squared because y goes into y, and y goes into y. And that's the smallest. Does that make sense?
I kind of
Okay.
just lost my own mind daily.
All right.
You kind of snapped me back right now.
Okay, so I multiply every single term by the LCD, which is y. And then these y's cancel, and these y's cancel. And what am I left with?
Y over.
Y plus 1. Yeah, you need to keep the plus 1 in there. All over. Y times x gives me xy plus x. Okay? Now what? In a denominator, there's a common factor of x. So I'm going to rewrite the numerator in parentheses so I remember to keep them all together. And then I'm going to factor out an x. And that leaves me with y plus 1. And now what happens? Those guys cancel. And I'm left with 1 over x.
There you go.
Yep. Question. Could I have canceled the y's out up here automatically? No. How come?
It's next to the x.
Because they're connected by addition.
Okay,
Because it's addition. It's either all of it or none of it.
Wait, so if there was subtraction, you could have done.
Last one, guys.
Wait, oh, you have to record it, remember?
Record it.
Example 4.
It was funny. I laughed.
You think what I said was on the recording? Actually,
What is the LCD here?
This is strange. What?
Least common denominator. So we're looking for the multiple. You're thinking of the factor.
36.
They both need to go into it. So it's 36. Yeah. So our LCD is 36 here. Because 36 has to go into it and 6 has to go into it. Okay? So the opposite of what you were thinking. Yep. So we multiply every term by 36.
Makes me happy.
Okay. So everything gets multiplied by 36, and then we cancel what we can. Okay. This 6 cancels, and 36 becomes 6. And then these 36s just both cancel. So what's left in the numerator? 36x plus 6 over
36x2.
36x squared minus 1. Okay? Now what can I do?
You can take out 36, or no, 6x from the top one, and...
I can pull out a 6 in the numerator.
Yep.
So that would become 6x plus 1 over...
6x.
What about the denominator?
Take out
That is a difference of 2 squares. So this would become 6x plus 1 times 6x minus 1. And now the 6x plus 1 cancel. So I get, in the numerator, 6 over 6x minus 1. Now, these 6's cancel, right?
Yeah.
Wrong.
Oh.
They do not. Why not? Because it has to be the whole thing. So because the denominator has subtraction, we just leave it like this.
So you're not canceling those?
We
but
cannot.
technically You are canceling those, but not really?
Wait, I thought, but even with the